A particle P is projected from the top of a tower 50 meters high with a velocity of 10I plus 20J meters per second. The origin is considered to be the base of the tower. Find the speed of the particle after 1 second. Find the greatest height above horizontal ground reached by the particle and the time at which this happens. Find the distance from the base of the tower that the particle hits the ground and the time at which this happens. And find the speed with which the particle hits the ground. So here's a diagram. This is the tower. This is our horizontal ground. The origin is the base of the tower. And here's our particle. And what we're going to do is fire the particle, and it's going to fly and land over here. So in part A, we want the speed of the particle after 1 second. For that, we can use v equals u plus at. So v at time 1 is going to be the initial velocity, 1020, plus 1 times 0, negative 9.8. Remember, a particle that's doing projectile motion is moving freely under gravity. And so that gives me 10.2 meters per second. Now that's the velocity. We want the speed, so we just use Pythagoras' theorem, and that's the square root of 10 squared plus 10.2 squared. And that's going to be 14.28 meters per second, correct to 2 decimal places. Now for part B, we want to find the greatest height above the horizontal ground. The greatest height happens when the vertical velocity component is 0, because that's the point at which the particle is no longer travelling either upwards and it's not started to travel downwards. So let's use v equals u plus at. So v is going to be 1020 plus 0, negative 9.8t. If we want the vertical component to be 0, then 0 is going to be 20, take away 9.8t. So 9.8t equals 20. T is 20 divided by 9.8, which is 2.04 seconds, correct to 2 decimal places, although I'll use the whole calculator display in subsequent calculation. Now we can use r is r0 plus ut plus a half at squared. We know that it starts at 0.50 at the top of the tower. Then we have 1020t plus a half, 0, negative 9.8t squared. The j component, when t is 2.04 and so on, would be 50 plus 20 times 2.04 and so on, plus a half times negative 9.8 times 2.04 and so on squared. And calculating that, we get 70.4 meters. So now for part C. The particle lands when the vertical displacement is 0. So what we need is for 0 to be 50 plus 20t, take away 4.9t squared. That's a quadratic, and we could solve it using the quadratic formula. We can see here that A is negative 4.9, B is 20, C is 50, and so we just substituted that in. I always start this by calculating the part under the square root, and then I'll go ahead and find the two solutions, and I get negative 1.75 and 5.83. Of course, the negative 1.75 can't be a solution here because we fire the object at t equals 0. So we get that t is 5.83 seconds. What we need to find out where the object lands is the horizontal displacement at this time. And so that's 10 times 5.83. Remember, all we're doing is substituting 5.83 into here and just looking at the horizontal component. So that's 58.3 meters. Now we want the speed when it lands, so we can use v equals u plus at. So v is going to be 1020 plus 5.83 times 0, negative 9.8, which gives us 10, negative 37.134. So the speed, just using Pythagoras' theorem, is going to be the square root of 10 squared plus negative 37.134 squared, and that gives us 38.5 meters per second, correct to 1 decimal place.